Welcome to Urban Agriculture Field Experiences, Lesson 7 of the Intro to Urban Agriculture, our Urban Ag Pests, offered by the Lehigh County Conservation District with support from the National Association of Conservation Districts, the Ryder Pool Foundation, and the Harry C. Trexler Trust. Disease-carrying, flea-infested rats caused the Black Plague which ravaged Asia and Europe in the 1300s. The disease, caused by insect pests, began with swollen lymph nodes and resulted in death in as little as 6 to 10 days after contraction. This plague claimed more than 50 million lives from 1346 to 1350. More than 60% of the European population was lost all because of fleas. In the 1870s, and again in the 1930s, grasshoppers plagued the Midwest in the United States during years already made agriculturally challenging due to drought. During these plagues, hundreds of thousands of acres of agricultural fields were quickly destroyed by huge swarms of large grasshoppers. The swarms were able to multiply rapidly because drought conditions hindered a fungus that normally kept the grasshopper egg population under control. A swarm of these insects could now mow even acres of stalks of corn to the ground in minutes. The impact of non-native insect species, otherwise known as pests, on farmlands can be devastating. Can you name the insect that devastated the entire peach industry in South Korea in less than 3 years? The spotted lanternfly. In Pennsylvania, the presence of the invasive spotted lanternfly, which arrived in the port of Philadelphia on a pallet load of stone from China, has the potential to cause more than $18 billion in agricultural damage due to hardwood, apple, grape, and stone fruit crop loss. In this case, the spotted lanternfly has very few predators to keep its population in check. Localized pests in indoor urban gardens include larger animals like squirrels and birds, or small insects such as aphids or cabbage moths. While gardening indoors, one might encounter aphids, fruit flies, mites, or fungus gnats. These pests generally damage the plant by feeding directly on the plant's leaves or by sucking the sap from the plants. During this unit, we will learn how integrated pest management or IPM strategies can allow for organic control of these destructive insects, often alleviating the need to move to chemical control. Students can observe insects up close and develop their own ideas for combating indoor and outdoor pests. Fruit flies, mosquitoes, longhorn beetles, gypsy moths, emerald ash borers, stink bugs, grasshoppers, Africanized bees, termites, aphids, cabbage moths, whiteflies, and spotted lanternflies. While the list seems like it could go on, it is likely that only 10% of our 900,000 identified insect species are pests. The other 90% of insects are beneficial or benign. And so while we may need to mitigate for pests from time to time, let's try to remember that most of our insect populations are essential for the health of our food web. Lesson PowerPoint Review. Lesson 7. Our Urban Ag Pests. Healthy food webs are key. Ecosystems containing food webs with great diversity of life are usually well balanced with energy and nutrients dispersed throughout, and healthy predator-prey relationships that keep population booms at bay. Food webs contain food chains populated by producers, the autotrophic life that makes its own food, like plants; consumers, animals that consume or eat the producers; and decomposers, the animal life that breaks down the organic material byproducts of the producers and the consumers. A healthy food web will have balanced trophic levels and little disease. When pests become persistent in a food web, the balance is offset. To bring things back into balance, integrated pest management strategies may be required. A living species varying from plants, fungus, animals, insects, etc., that is not native to an area and often multiplies, threatening the health of the local natural environment or community. Often, invasive species thrive in a new non-native environment because there are no competitors which allow for exploitation of resources in the area in which they are establishing. Invasive pests often impact a region's economy as well. Local invasive insect examples include the gypsy moth, which deforests trees, stink bugs, which feed on fruit, and spotted lanternfly, which feed on tree sap. Each species weakens the health of many of our native trees. While some invasive species arrive in the environment by accident, some are brought for a purpose. European settlers introduced honeybees into the United States knowing that they would be essential for pollinating their gardens. These non-native bees began making hives in the nest cavities of trees, nearly leading to the extinction of bluebirds, which are cavity nesters. Controlling for pests has been taking place for several thousands of years. Humans have been using chemical methods such as sulfur, mercury, arsenic, and smoke to kill pests in agricultural settings. Not all historic management was chemical, however. Lenape Native American boys would perch on stands high above their family's garden, armed with pouchfuls of rocks which they would pitch at any animal that came close to the vegetables and fruits that they were growing. Dichloro-diphenyl-trichloroethane. The chemical DDT was developed in the 1800s. Though, as a broad-spectrum pesticide, or one that killed a wide variety of pests, it became very popular in the agricultural world and on most continents in the 1940s. It even earned Dr. Mueller a Nobel Peace Prize. Dr. Mueller was a Swiss scientist who used it to alleviate diseases caused by insect pests like the bubonic plague, malaria, and typhus. DDT was first used by the military to control disease, but after World War II, it was also used in the agriculture industry as a crop pesticide. Although DDT is clear, odorless, and tasteless, It does not break down in nature and actually bioaccumulates in the tissue of animals. Because of this accumulation, DDT is often found at the top of the food chain. For example, a fish becomes contaminated with DDT from the runoff of a farm field. It is then eaten by a raccoon. The raccoon is then eaten by an eagle, which accumulates all of the DDT that was in the food chain it ate from. DDT has particularly had an adverse impact on birds of prey because it weakened the shells of eggs laid by females. These shells were crushed by incubating parents, which led to the widespread decline of many birds of prey species. According to the EPA, DDT can cause liver damage including liver cancer, nervous system damage, congenital disabilities, and other reproductive harm in humans as well. Integrated Pest Management, also known as IPM, a human and environmentally friendly strategy employed by growers to reduce damage of pests while aiming to increase crop yields. IPM strategies are meant for long-term impact. Initially, proper idea of a pest is necessary for determining if management is required. IPM can involve a variety of the following strategies. Biological control, utilizing natural enemies in nature to control for a pest. Cultural control, employing different human practices that help lead to the decline in pests by decreasing breeding, dispersal, and survival. Mechanical control, physical controls that help block or kill a pest, like traps. And chemical control, used as a last resort and employed often in tandem with previous controls, with great care to have the lowest possible impact on surrounding ecosystems. For example, in Pennsylvania, when the spotted lanternfly is suspected, pest management specialists will survey properties for signs to properly identify the insect. Inspection for egg masses, nymph instars, or adults, depending upon the time of the year, will occur. The location will also be surveyed for the tree of heaven, a known host plant. There are insects and animals that have been identified preying on the spotted lanternfly, however there are no biological controls currently available for purchase. Cultural controls include humans looking before you leave to make sure the insect population isn't spread and seeing and squashing these insects at any life instar. Mechanical controls used to reduce the spotted lanternfly populations include sticky tree banding. Finally, systematic tree drenches and squirt and hack methods of infected trees are examples of chemical controls employed upon last resort. For more information on integrated pest management, visit the website provided. An organic insecticide that utilizes a fatty acid-based vegetable soap, often castile liquid, solution which permeates and destroys the outer body of an insect leading to the dehydration and often paralyzes the pest. Companion plants are plants that gardeners and farmers grow to encourage beneficial organisms and discourage unwanted pests. For example, marigolds are planted to attract pollinators to a garden and deter unwanted deer. Also, the Three Sisters story that tells the Native American legend of planting corn in the center of a circular garden, then beans to surround the corn to utilize the corn as a trellis, and then finally prickly-leaved squash in the outside circle to keep animal pests away from the inner crops, which is also an example of companion planting. Crop rotation, a strategy of planting that involves planting different crops in subsequent seasons and not allowing any one pest to repeatedly become attracted to the host crop. In addition to discouraging pests, farmers employ this method to retain quality nutrient content in the soil. The spotted lanternfly, an insect in the plant hopper family that has 2 pairs of wings and hops to move from place to place. It is native to southeastern Asia and feeds on the sap of more than 70 different trees native to Pennsylvania, such as maples, pines, stone fruit trees, and grapes. It is an invasive species in the United States and arrived here on the Tree of Heaven in 2014, reportedly in the egg mass form on a pallet of decorative stone from China. More than 24 counties in Pennsylvania are now quarantined for this invasive pest. Spotted lanternfly presence threatens to impact $18 billion of industry of hardwoods, apples, grapes, and other stone fruits. The life stage of a spotted lanternfly insect starts when it hatches from an egg until it reaches adult maturity and lays eggs. Spotted lanternflies drink tree sap, grow larger, and molt the outside skin between each stage. A spotted lanternfly is black with little white spots and the size of a tick when it first hatches. After growing bigger and molting, it grows larger 2 more times. The insect becomes red and white during the 4th instar. In another month, the insect will grow wings and become an adult, and after another several weeks, this adult spotted lanternfly will lay egg masses. This cycle takes approximately 1 year. The insects hatch out in mid-April and lay eggs in November. These adult spotted lanternflies will die before the weather warms up. The Tree of Heaven, scientific name Ailanthus altisma, a deciduous tree native to China that grows in temperate climates and has become an invasive tree species, now classified as a noxious weed in North America. This tree is the host tree for the spotted lanternfly, and it is thought that they might carry out their life cycle on it. Tree of Heavens were brought to the United States in the early 1800s as fast-growing street shade trees. When mitigating for spotted lanternflies, a male trap tree treated systemically with insecticide may be left among the stand of Tree of Heavens. The female Tree of Heaven trees surrounding the male trap tree have been killed via hack and squirt method. This male trap tree will attract spotted lanternflies that will die after feeding on this treated tree. During the 7th week of the course, educators can use the vocabulary lists and activities provided in Our Urban Ag Pests to give students a basic background regarding IPM strategies that are used in agriculture. The outline DDT game will help students to understand how bioaccumulation of hazardous chemicals such as DDT in the environment in the early 1900s led to the new integrated pest management strategies that are utilized today. They will move on to learning about companion planting and pest control strategies used by pre-colonial Native Americans that are still used in backyards today. Students can also practice small-scale mitigation strategies by creating fly traps to help with indoor pests.
Hi, my name's Jolie Shilek, and thank you so much for joining us today for this installment of our urban agriculture curriculum. It's brought to you by the Lehigh County Conservation District. And the lesson that we're working on today is lesson 7. It's our urban agriculture pests. Pests, what are they? Well, they're unwanted living organisms that invade our growing spaces. In farms, if you think about it, you might consider a deer a pest if it's eating your crops, or rabbits even, or little mice. In cities, it might be a bird, several birds, and certainly squirrels, raccoons, things like that. But then there are the insects, which invade almost every growing space, even the indoor growing spaces, because they can be brought in on plants and that sort of thing. And there are about 900,000 species of insects that we've identified, but scientists believe that there are about 2 million, anywhere from 2 million to 30 million insects that we haven't found yet. And so that's a lot of opportunity for pests to invade our growing spaces. So I thought I'd talk to you a little bit today about what to do if you feel like you have a pest problem with your plants. Pests that sometimes invade our plants could include anything from white flies, cabbage moths, aphids, of course, and all sorts of things like that. Here in the eastern part of Pennsylvania, we're dealing with the spotted lanternfly, and so we're very worried about how they're going to affect our hardwood species and some of our about 70 native trees, especially fruit trees. So we've been working on ways to control for pests in our growing spaces, and we want these ways to be environmentally friendly, organic if possible. And one method that we found that works very well is using Castile-based soaps, insecticidal soaps, which are really just soaps that have a type of vegetable oil in them. Castile-based soaps, the Castile is actually olive oil, and the olives are grown in Castile, Spain. That's a region there. The olive oils contain a fatty acid, and that acid is detrimental to the insect because it destroys the outer layer of their exoskeleton, and it then leads to dehydration and paralysis in some cases. So you can find this type of soap in a Whole Foods store, an organic grocery store, health food market, and you should look for it in a liquid base. Typically on the label it tells you how to make this insecticidal soap and what ratio you need. You need about a tablespoon for a quart size container, which I have right here. So you need the soap, you need a container, you need some water, and of course your tablespoon. Okay, so you need to take a tablespoon of this soap, and actually if you have a container that you can put the water in first, as in don't put the soap in first if you're going to fill up the container through a spigot, because you can imagine all the bubbles that are going to come out of it. And you want to put a quart of water in, and it takes filling it to the top line here to reach a quart here. So you can put the soap in first if you have the water in this kind of situation. And it won't bubble up because we're going to pour it in kind of slowly. Okay. Go there. And then, of course, we'll just put our lid on and turn over a few times. Again, like my students have done, it's a good idea to carefully label this. You can say what's in it, that the Castile soap is in it, and water. And you can if you're doing this in a class, you can name it. Dye spray in this case. But it is an insecticidal soap at this point, and is safe for your children to handle and to be used on the plants. You should test your plants, like maybe for a day before you want to use this soap. Just test a little bit of the solution on the plant to make sure that it's not going to have an adverse effect. But then when it's time to spray it on, you can spray it about once a week if you have a minor pest problem. If you have a major pest problem, you could probably spray it 2 times to 3 times a week. You should spray on the upper side of the plant and beneath, because remember, some of our pests are laying their eggs underneath, and this is also going to be effective in killing those eggs or small caterpillars in any life stage. You also want to make sure that you don't spray this on plants that are stressed in any way, because this could hurt them if they're already compromised. So this is a really a good project for the kids. They often enjoy naming their own product and that sort of thing. We feel comfortable about using this out in the environment. We know it's because it's a vegetable-based soap. It's not going to hurt anything, and is a good way to control for pests. I do want to say that I've read that 90% of our insects are either beneficial or benign, and only 10% of them are pest insects. And so I am not an advocate of killing insects when we don't need to. So please only use this on the harmful insects that are eating away at your plants. And other than that, I hope you enjoy working with your students to make a little insecticidal soap. Thanks so much.
Mixing an insecticidal soap and designing its container as directed in this lesson's do-it-yourself video can serve as a great chemistry lesson in mixing solutions. The resulting insecticidal soap is useful for controlling unwanted pest populations in an indoor lab. In districts and schools in Pennsylvania where spotted lanternflies are present, there are opportunities to extend Lesson 7 by investigating adult and nymph insect life stages under the microscopes. A worksheet may be found at the end of the Lesson 7 to facilitate this activity. Teachers can also take students on egg scraping and/or tree banding walks around the school. Local conservation districts may also be able to join the class for a lesson on the walk. Consider giving students basic materials such as straws, toothpicks, duct tape, popsicle sticks, and jars to hold a design contest for a new spotted lanternfly trap. Try the traps out on live insects if there is an opportunity. Pest control can often be aided by introducing predator species into the garden space. Native praying mantids and ladybugs are predator species that can be introduced organically to take care of pests. If a teacher has access to a flock of chickens, one may be brought into the classroom and a brainstorming session about their benefits in the urban ag setting can be facilitated. Chickens are useful in keeping pest species down as they feed on pest insects and ticks. Hens lay eggs, which also contribute to a healthy food resource. Their scratching behavior allows for soil to be aerated and can help with weed control. Finally, their droppings can be added as a nitrogen resource to compost piles. We hope you enjoyed our quick lesson on the Intro to Urban Agriculture, our Urban Ag Pests. For more information on the Urban Agriculture Field Experiences lesson plan, visit www.lehighconservation.org or follow us on our Facebook, Instagram, or YouTube pages. Thanks for watching, and be sure to check out the rest of the videos in the Urban Agriculture Lesson Plan series.